Today we're going to be talking about wind, or horizontally moving air caused by uneven heating of the earth. And this uneven heating causes areas of different pressure to form. When areas of high pressure push towards areas of low pressure, that's what creates the breeze that we feel on Earth. And the difference between the distance between the high and low pressure areas causes the different wind speeds and directions that we experience. We see two different kinds of wind patterns on the Earth. One is local, which are winds that move small distances close to Earth's surface, and these are dependent on the terrain of the area. And also we experience global wind patterns, and these are winds that move great distances over the globe, often high in the atmosphere. These global winds are categorized by the latitude, or their distance from the equator. There are three major types of global wind patterns. One of these is trade winds, and these are winds from 30 degrees north to 30 degrees south that blow from east to west towards the equator. So as you can see here, both of these areas of winds in the northern and southern hemispheres are blowing from east to west and joining up at the equator. The next type of global wind pattern that we see is the prevailing westerlies. These are winds from 30 to 60 degrees, both north and south, that blow from west to east towards the poles. So as you can see in the red, these both originate in the west and blow towards the east, towards the pole in either the southern hemisphere or the northern hemisphere. The last global wind pattern that we observe are polar easterlies, and these are winds from 60 to 90 degrees in high latitude, both north and south, that blow from the east to the west towards the equator. So here in the southern hemisphere, they blow east to west up towards the equator, and then in the northern hemisphere, they blow east to west down towards the equator. Due to Earth's tilt is the reason that we have these three different patterns. If the Earth wasn't tilted and the uneven heating didn't occur, we would have only one major global wind pattern, where air would move from the equator towards the poles and circulate back up towards the equator. Another type of global wind that we experience is the jet stream, and these are narrow bands of strong winds in the upper atmosphere. These move from west to east, but often change to flow north to south and follow boundaries between hot and cold air. These are the strongest when the boundaries between the hot and cold air is most pronounced, and that happens to be during the winter. So jet streams are strongest and most pronounced during the winter. As you can see here, this jet stream is flowing from west to east around the Earth along with its rotation, and they are typically about 1,000 to 3,000 miles long and 1 to 3 miles thick. As you go closer to the center of the jet stream, the speed increases. Two examples of local winds that we experience are both sea breezes and land breezes, and these are both types of convection currents, which are continual cycles of heat rising, cooling, sinking, and replacing rising heat. In this case, we're considering convection current an air process, but we also observe convection currents happening in water and in the ocean on our Earth. Sea breezes are convection currents where air flows from the sea to land during the day. This is due to the uneven rates of heating on the Earth, where land heats up faster than the sea does. Land breezes, on the other hand, are convection currents where air flows from the land to the sea at night, and these are due to uneven rates of cooling. The land cools down much quicker than the sea does, causing this wind pattern to be observed.